So we are discussing our subject named industrial instrumentation, and we have concluded up to module one, which is a temperatures measurement. In temperature measurement, we have discussed about the thermocouple, RTD, and thermistor, and other diode type sensors we have discussed. In this class, we will discuss the pressure measurement, which is given our module number two. There are many uh, techniques for measurement of pressures and vacuums. The instrument used to measure pressures are called as pressure gauges. The pressures of a fluids measured by the manometers or mechanical gauges. Different type devices then used to measure the pressure. One of them is the manometers and other device. What are the manometers? Manometers are defined as a device that is used to measuring a pressure at a point in a fluid by balancing column against the same to another columns of fluid is known specific gravity of manometers. Means this manometer defined device is measuring pressure of a point. In a point, it is measuring a pressure of a point in a point the fluid by balancing the fluid column against same or another column specific gravity. Suppose that this is the YouTube manometer like this. Initially, it is a level or same. When the pressure is applied on this, so this liquid start to downs, and here this liquid move up. Here it move up. So this height, this new level, and this height is h. Then we can calculate the delta P equal to rho g h. Rho is the density of this liquid, and g is a 9.8 meter per second. H is this height. After applying the pressures here, so this liquid move to upwards, so level increases. So in this level in this leg move to downwards. This point differences with height. So in this way, by balancing the against column against same or another column, that's balancing by this is known. So there are three types of manometers: simple manometers that use the piezometer tubes and U-tube manometers. Next is a micrometers or single column manometers. Manometer, the single column manometer, or vertical column micrometers or inclined micrometers. Third is a differential manometers. So U-tube inverted manometers are there. We will discuss one by one in futures. Mechanical gauge. What are mechanical gauges? Mechanical gauges are defined the devices that are used for measuring the pressure at a point in the fluid by balancing a column of fluid by spring or dead weight. Simple U-tube manometer. It consists of a glass tube. Simple U-tube. This is the like simple U-tube manometer, and this is the here we have apply the one side pressures, and this is the atmosphere. In this way, this will look like a simple U-tube manu. Piezometer tube. It consists of the glass tubes connected to vessel or pipe, which has static pressure to be measured. It is a simple and all manometers used to measure the very low pressure. This is used measure for very low pressure, which which is static pressure to be measured. Here, 2 points must be memorized. For it used for static pressures, and second used for very low pressures. Limitation of piezometer tube: it cannot measure high pressures. Second, and it cannot measure the vacuum or negative gauge pressure because it measure only static pressures. This look like a piezo tube. The pressure in piezo tube is given following equation. Pressure equation generally rho P barabar rho G H is given by this. H is height of liquid. This is the height liquid, or this can height of liquid. Rho is density of liquid. G is acceleration of liquid. Next, this is the U-tube manometer. This is the U-tube manometers for gauge pressure for vacuum. It consists of a glass tube U shape, one end of which is connected to a point which pressure to be measured. Suppose that we want to measure this vessel pressure. So we can connect it one tube to this. The pressure to be measured. Here pressure to be measured. This point to be measured. And other end remain open. And this and this must be atmosphere temperatures. The tube contains generally the liquid filled by this tube is generally mercury or any other liquid may be whose specific gravity is greater than specific gravity of liquid whose pressure to be measured. So second thing we have to memorize, the liquid is filled, the specific gravity more than the liquid which we are measuring. For gauge pressures, and for the gauge pressure, this is the four. This diagram look for gauge pressure. This gauge. So let B is the point with the V is a point at which pressure to be measured. With inside this vessels or tubes, the point B here, the pressure should be measured here. The point B, the pressure should be measured, whose value P is the datum line A dot A, the H1 height of the liquid above the datum line, H2 height of heavy liquid above the datum line, H1 height of liquid above the datum line. This is the date. Suppose that this is the datum line. This is the datum line. H1 height of liquid above the datum line. H2 height of heavy liquid which is filled above the datum line. This is the filled liquid, heavy liquid. The, this U2 manometer should be filled heavy density than compared to the pressure to be measured. So then, as when the specific gravity of light liquid which means this is the light liquid. This is the light liquid. Height one is here we are saying this is the height 1, then height 2, this is the height 2. The density of light liquids equal to the specific gravity in thousands, density of heavy liquid root density of heavy liquid equal to thousands gravity of water, because this we can use the water here for measures water. So less pressure to be measured, we can use this formula rho gh P plus rho gh. So I think no need to do the derivation because this is not our mention also. We know this how to use the for vacuum and how to use the liquid in the gauge. This is the gauge diagram. This is the diagram. I think this is a not need to this is not need to the measure the temperature differences. Not need to measure the this derivation not required for our list, not our for syllabus only. We should know this. If we want to do this, so H pressures, so we can type this formula. This is the rho gh. They suppose that this is pressure P plus H height up to here plus H height, this pressure plus rho GH, again on pressure rho GH if you want to do. And for A datum, right side, if this is the left side column pressure, right side column pressure rho GH2 into this height, hence the operating two pressures must be equals. So P plus rho GH1 plus P, in this way we can calculate the P. Similar with this, not need to calculate this derivation if you want to calculate. There is a micro manometer or single column manometer. Micro manometer modify of U2 manometer. Micro manometer is also known as single column manometer. This construction of micro, one limbs of micrometer is a tank of large cross section areas compared to cross section area other limbs. These tanks act as a reservoirs to hold the manometer. The cross sectional area of the tank is 100 times greater than other limbs. When there is a change in pressure in pipe, so there is a negligible change in a level of fluid tanks. This change can be neglected and pressure to be measured the height of this liquid column. It is a two types: vertical column micrometers or inclined column micrometers. So vertical column micrometers, this is the vertical column micrometer. This is the vertical column when there is no fluid in pipe, the level of manometer is xx. Where is xx? This line is xx. If there is no fluid in pipe, this line is xx. But due to liquid pressure in pipe level, the man of manometer, the liquid move from x to y due to liquid pressure in the pipe vessel. So this level move to delta H changes at this position from x to y, and the tank in the tank and the rise in the limbs to the distance h2 from xx. So the rho is the density of liquid for which pressure to be determined. Rho is density, and the rho 2 is the density of manometer. Rho 2 is the density of manometer to be assume. This another the inclined type. This is the inclined time manometer or micrometer. Inclined time manometer more sensitive vertical initially when there is no fluid flowing through this level of micrometer. It has, but is due to liquid pressure in pipe level of manometer move from xx to yy. Suppose this is the no manometer. Suppose here this in previous this pipe was not inclined. But in this pipe is inclined. Rho is density and not need to derivation this formula. Use only memorize this diagram and how to the measure the pressure for inclined. Another differential manometer. Differential manometer are used to measure the differential pressure between the 2 points in a pipe and two different pipes. There is a two type of differential manometer: U-tube or upright differential manometer, U-tube or inverted differential manometers. Two pipes different level, A and B are at same level. So this is the two pipe different level U-tube manometer. U-tube upright differential manometer. Different type of different manometer we can study here. Not need to do the derivation, only should write the type of manometer. Inclined column micrometers. This is also same differential manometers. This is the inverted U2 manometer. This look like the inverted U2 manometer. Where it consists of a U2 and containing a right liquid. There is a two end of tubes are connected to points whose temperature to be measured. It is used for measuring difference of low pressure measuring. So the inverted U2 differential manometer connection with point A and B. And next is the topic we will discuss about the next class mechanical gauges.